So, hey guys, how are you all doing? So, in this video, we are going to discuss how to solve this equal sum grid partition from the Leetcode daily question challenge. So, here we are given with the which I'll take my go to explain. Actually, if you see the question, here you are given with an m into n matrix grid of positive integers. Your task is to determine if it is possible to make either one of the horizontal or one of the vertical cut on the grid such that each of the two result sections formed by the cut is non-empty and the sum of the elements in the both sections should be equal. So for example, if you consider this one, so I will take my take this example and explain 1 4 2 3. So if you take an example of 1 and 4 and 2 and 3, so this is the 2D array. Here if you see either any of the cut like an horizontal cut or an vertical cut, we need to consider either of them and we need to check like if we consider here the horizontal cut, the sum of this value should be equal to the sum of the next value. The sum of the first row should be equal to the sum of the second row. So when both are equal, then what we can say? Then we can say it is true. So based on the given condition here, equal sum grid partition. So this is an equal sum grid partition. We can return this as true. So if you take another example here as what they again 1 3 2 4. Wait a second. 1 3 and 2 4. We need to check either these two or these two. And here consider right. When we consider the horizontal, we need to check the first row and second row are equal or not. What we can do, we'll add this. This value is 4. This value is 6. So this is not possible. So we'll consider first row and first column and second column. And then we will check. We will add these values and we will add these values. So if we add this value, what we got? We got 3. So this is also not possible. So this is 3. And this one is 7. So this is also not equal. So what we can do here? So this is how we need to check two conditions. What are two conditions? We need to check in the row manner or column manner sum, like row sum or column sum. So if we observe here this one, what we can see, we have got the equal parts here. So when the equal parts, so when we got the equal part, so when we try to add the total elements present in the total sum, so for the 1 4 2 3, if we add total, our value should be 1 plus 4 plus 2 plus should be 3. That should be equal to 10. So this is a condition. So this is a value we got as 10. So when we divide this into two parts, what we have got? We have got a value of 5. That's right. We have got an equal value here. So what we need to do? We need to check if our either any of the part, any of the one part of row, or if any of the one part of column is equal to the target. So this value, what we can say, we can return true. Or else we need to check, if we have checked the column, we need to check the rows also, like that. So after all checking, if either any of the possibility is not present, we can return it as false here. We can return this as false. So I hope you guys understood what I'm trying to explain. So we will now go to the coding part and do that. So as I said, so if we see the constants here, the size of m and size of n are from 1 to 10 to the power of 5. So we need to take the data type as long here. We need a long type of data types here. For what? For the summations. For the summations and the target values, we will take the not integer, but we will take long. So if you take an integer value of integer m as grid dot length, we need to check integer m as grid of 0 dot length. That's it, right? Yes. After considering this, we need to take an total value as 0. And what we need to do? We need to add all the values. All the values. We need to add all the values. So as we see here, the sum of the elements in the both sections should be equal. That means if the both are equal, our target sum can't be in what? In an odd. Our total sum can't be in a not total sum. Our half of the total sum should be an divisible part by 2, because if it's not divisible by 2, then one of the total sum, so the total sum becomes an odd number. So when we have an odd number, we can't give a equal partial amounts to both of them. So that's the main thing we need to consider. So as I said, we will consider long value, and so we will take a for loop here and start our int I equals 0 and I. We go to the grid length, we will take for int j equals 0 to j is less than n, and I will also increment j. What I do, I will add the values, the grid of I comma j. What the grid of I comma j here, and I will check here. What the thing I need to check here, if our total percentage 2 is not equal, if it is not divisible purely, then what we can do, we can just return here itself false, because when we do not have an equal partial amounts, then we can't make equal sum. Then we can't make the equal sum. So after considering this, we will take a long row sum as 0, and I will do first the row sum. When I have a test case like 1 comma 4, 2 comma 3, I will check either when I consider like this, if my total divided by 2 is equals to the sum of the first order iteration, then I can return to this value. If 5 is equals to 5, I can return to either here or here. If it is not present, if it is false, I need to check like this. Okay. So you can consider this one itself. We will just change the values. So what we need to do here, we need to add this into the row sum. So here we have not done something. So if the value is purely divisible, what we need to do, I will take a long and mark it as target, and what I do here, I make total divided by 2. I will make it into the two parts. So after that, so after adding each row sum, I will check here itself. If my, as I said here, I will check here itself. I will check here itself. I will check. My row sum equals to the target. Then what I can say, I can return true. So same goes for the column also. So for column, so for 1, 4, 2, 3, we have checked the rows first, but here we need to check the columns first. Like this, we need to check, and like this, we need to check another time. Like we need to check this one is 3, and this one is 7. Like this, we need to check here. Hope you guys understand me. So as I said, we need to use our J loop here. First, we are iterating through our J plus plus integer I equals to 0 is less than 10 I plus plus. Then we do here. We have not taken the value of column sum. Column sum also I am initiating it as 0, and then adding the value of grid here. We can check here to adding the values. What I need to do, same, I need to check here also, but here I need to check for the column sum. So for the first iteration itself, we will know in either of the, so for the first inner iteration total completing only, we will get to know if our column is true or row is true, because after the first total completion of the second inner iteration only, we are checking this value. So if our checking equal sum is true, then we will not check total iterations here, but we will just return here itself. So that's why our time complexity will also be reduced here. So when you also check all the things and you don't got anything, you just return this as false. So I will run this and check. Got any spelling mistakes. Okay, I hope this would work. Yes, it got accepted. We will also try to submit and check. Yes, it is also accepted in the submission also. So I hope you guys understood. And if you guys have any doubts, please get clarified from the comment sections. I will be help you guys if you have any doubt. So that's for this video, guys. Thank you for watching. And if you guys like the content and the way of approach I explain, the way of teaching, so please do like and subscribe. That's make me more motivated towards teaching new concepts and helping you guys. I hope you guys understood. That's it from my side. Thank you guys.